Hello everyone. In this video I will discuss Huckel theory for conjugated pi electron systems. Okay, this is introduction. Okay, introduction part. The one page, two page. This is introduction part. Okay, after that I will discuss that some question how to solve. Okay, so first of all say this one. Uh, this theory, that means introduction part. This theory was originally introduced to permit qualitative study of the pi electron systems. Okay, now qualitative study of the pi electron system. Pi electron system, all of you know this one. Suppose one example, CH2 double bond CH2. So here pi electron system is there. One is pi, another one is sigma. So pi electron system, this one is example, one example. Or another example, suppose like this. Okay, so this one here pi electron system is there, one pi electron, two pi electron system is there. Or you can consider then benzene. So this one also pi electron system. Suppose this one like this, this one is butadiene. This one also pi electron system like this. Understood? So this is what this theory was originally introduced to permit qualitative study of the pi electron systems in planar conjugated hydrocarbon molecules. This one planar, it will be planar or conjugated hydrocarbons. You know this one is conjugated hydrocarbons meaning. Okay, it is thus most appropriate for molecules such as benzene. Okay, such as benzene. Then in benzene structure there are how many pi electron system is there here? The three pi electron system. Okay, and butadiene also they have two pi electron system, but the approach and concepts have wider applicability. Okay, so this one is introduction. Okay, now some basic assumption is there. Basic assumption also important, but in exam time cannot come this one like this. But this theory part, that means this you have to understand. Okay, this part. So basic assumptions. First one, the atomic orbitals contributing to the pi bonding in a planar molecule. Example, this example is so pi p-pi orbital in a molecule such as benzene. Okay, so such as benzene, see, this one is benzene. Okay, this one is benzene ring. So here p orbital is there like this, p orbital. Okay, so this one okay, overlap, will overlap this one, this one, this one, and this one. Okay, like this. So here p pi. Okay, p orbital and then pi. So that's why this one is what? P pi orbitals in a molecule such benzene are antisymmetric with respect to reflection in the molecular plane. Okay, this one is antisymmetric. So symmetric, antisymmetric, you know this one. Symmetric, which part is symmetric, which part is antisymmetric. Okay, this one in group theory is there. Okay, group theory part. They are therefore of a different symmetry to the atomic orbitals, contributing to the sigma bonding and may be treated independently. Suppose this one, see, this one is s orbital, or suppose s, this is ss, or suppose p. Okay, p sigma. So they had, this is s orbital, s or p sigma, this one, and this one p pi orbital. Okay, p pi orbital. So you know this one is p orbitals. P orbitals is 3p orbital is there. Okay, and 3p orbitals. First is like this. Suppose this along x-axis. Okay, this one is along x-axis, and along, suppose this one is y-axis, along y-axis, and another one is along z-axis. So this one is pz. So pz, and this one is px and py. Understood? So this one is mirror plane. This p word is mirror plane of molecules, any molecules. Okay, this one. So this is basic, first one. Okay, second number, see, the Coulomb integrals for all the carbon atoms. All the carbon atoms are assumed to be identical, that is, small difference in alpha values due to the different chemical environment of carbon atoms in a molecule such as this one are neglected. Okay, see, 1 2 3 4 carbon atoms are there. Okay, sorry. So this one is what? The Coulomb integrals for all the carbon atoms are assumed to be identical. Now you have to assume that one is what? Identical. Assume to be identical, that is, small differences in alpha values due to the different chemical environment of carbon atoms in a molecule such as this part are neglected. Okay, this one. Point number 3, all resonance integrals between directly bonded atoms are assumed to be the same. That means all resonance integrals, this one is what? Directly bonded atoms are assumed to be the same. Okay, to be the same. So wise list this between atoms that are not directly bonded are neglected. Okay, the another one is not directly bonded to the atom. Suppose this one, see, integration phi I h cap phi j d tau equal to beta if atoms I and J are directly sigma bonded. If directly sigma bonded, then this formula have to apply. This formula is what? This symbol is this integration symbol. So integration phi I h cap phi j d tau equal to beta. Okay, this one. Or suppose this one is this value is 0. Suppose this value is 0. Okay, you can consider here 0. So when this one is 0, when will be 0? If atoms I and J are non-bonded. If non-bonded, this atom I and J are non-bonded, that means this value will be 0. Understood? So this one is 3 number point. 4 number point, this one is all overall integrals representing the overlap of atomic orbitals are centered on different atoms are neglected. Okay, this one is 4 number point number 4. Now this uh, this one is what? Integration phi I phi j d tau equal to 0. If I not equal to j, that means this I value, suppose I value is 1 and j value is 2, so this one is not equal to. Okay, not equal to. You can consider any value, this one I and this one, but this one never be same. Okay, this one is different, that's why this one. So this 4 number, all overlap integrals representing the overlap of atomic orbitals centered on defined atoms are neglected. Okay, this one. And this last part is note, this is important point. I equal to j, then integration phi I phi j d tau equal to 1, since it is assumed that the atomic orbitals are normalized. So when will be normalized? Atomic orbitals are normalized, that means I equal to j, that means I, suppose I value is 1, okay, and j will also 1, suppose I value is 2, then j will also 2, then that time this equation is what? Normalized. Okay, so this one is basic assumption. Okay, so you have to know this basic assumption of Huckel's theory. Okay, this one. Now its main point, this one is sorry, linear conjugated hydrocarbons. Now linear conjugated hydrocarbons, the general solution, n atom chain. Example, CN HN plus 2. This is conjugated polyenes. Okay, conjugated polynomial, so this one is first. Okay, so orbital coefficient are given by the orbital coefficient. This formula, one formula needed. This formula is orbital coefficient formula. Okay, formula is carbon s, this is carbon, so carbon s directly proportional to sine pi k s divided by n plus 1. So this is formula. So carbon s directly proportional to sine pi k s divided by n plus 1, where n equal to, this n equal to what? N equal to total number of atoms in the conjugated chain. That means the total number of atoms. How many carbon atoms like this? Okay, this is total number of atoms. S equal to atom number. S equal to atom number. This atom number 1, atom number 2, atom number 3 like this. That is 1, 2, dot 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 n. This one. After this is K. This one is quantum number identifying the molecular orbital. Though this K value is, you can consider 1, 2, 3, 4 like this. Okay, you can consider. And the constant of proportionality can be determined by applying the normalization condition. Okay, this is normalization condition. Understood this part? Now one example. Okay, suppose this one. Consider the highest energy MO molecular orbital of the 3 carbon chain. Now 3 carbon chain, this n value is what? N value is 3, and this k value is there, k also 3. Suppose this is formula. Cs directly proportional to sine 3 pi s. Okay, 3 pi s. That means this one was k value. This k value is what? K value is 3. Okay, this is formula. This formula. So here k value is what? 3, and n value also 3. 3 plus 1, then this one. Suppose s value is 1. Okay, so s equal to what? S equal to atom number. So suppose s1, then you will get this one. Then the answer is this one. You know this one, this is a trigonometric, actually trigonometric function. How to do this one? So sine this pi by 4, this 45, this value is this one. Okay, second number, this one also same process. Now this c2, that means c2 value. Okay, c2 second number. Now you have to put this one also. So here value is -1. Okay, next. Okay, sorry. Now the third one, C3, the alpha, this one. So you know this one is sine 9 pi by 4 equal to, this is half. Okay, so these coefficients are not normalized. To achieve this, we need to multiply them all by the same constant value chosen to ensure that the new values of the coefficients satisfy the conditions that the summation. So the summation ci whole square equal to 1. Okay, this one. So you have to know this formula. Okay, this is very important. So you have to practice this formula. Now for linear molecule. Okay, for linear molecule, this is formula. Ek equal to alpha plus 2 beta cos pi k by n plus 1. Okay, this cos pi k by n plus 1. This is this one is for this formula for linear molecule or linear molecular formula compound, for linear molecular compound. Okay, this one. Here n equal to what? N equal to total number of atoms in the conjugated system. Okay, n equal to the total number of atoms means the carbon atoms. How many carbon atoms? Okay, this one, this n. Understood? Now k, this k value, this is quantum number identifying the MO. That means k value you can consider 1, 2 dot 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 like this. Okay, 1, 2, 3, 4 like this you can consider. Understood? Now note that the cosine function varies only between the limiting values of -1 and +1. Okay, this one, that means cosine value. Cosine means cos value. Cos values varies from this limiting values of -1 and +1. This one, that is like this. Okay, see this one, -1 less than equal to cos pi k divided by n plus 1 less than equal to +1. Hence this one, alpha plus 2 beta, this is energy. Okay, alpha plus 2 beta less than equal to E less than equal to alpha minus 2 beta. So how will came here? Okay, this one, so I'll discuss this later. Okay, so this is formula. This one is linear molecular compound. For linear molecular compound, this one is formula. Suppose this one is ethylene. Okay, ethylene or allylic cation like this. Okay, or anion or radical. This formula have to apply. Okay, now this one is very important one from equation. This one I think came in 2000 exact year, so I don't know, I forgot this one exact one. Okay, no problem. So how to approach in this question, you have to see using Huckel molecular orbital approximation. The two roots of circular equation of ethylene ethene are, now which one is current? Ethene. So ethene needed. Okay, then CH2 double bond CH2, this one ethene. Suppose this one. Okay, see, this is formula. EK equal to alpha plus 2 beta cos pi k divided by n plus 1. K value is what? K value 1 2 3 like this, and n equal to number of atoms. This is number of carbon atoms. How many carbon atoms? Okay, this one. Suppose K value is 1. Okay, if K value is 1, then K here 1, and N value, now N value, this one is in ethylene molecule or ethylene molecules, how many carbon? Here only 2 carbon, so 2 carbon, then this one, then 2, here you have to put 2 plus 1, then 3. Okay, pi this one. Now cos pi by 3 value is what? Cos pi by 3 value, so this one 1 by 2, then this one cancel, you will get alpha plus beta. Now K value is 2. Suppose K value is 2, then E2 equal to alpha plus 2 beta cos 2 pi by 3. This one, because this n value is what? Number of carbon atoms, 2 plus 1, this one, then you will get like this. And then this one too, you can, this is unity function, then alpha minus beta. So first one is for K equal to 1 alpha plus beta and K equal to alpha minus beta, 2 ethylene unit. Okay, see, so which one is correct? This a number root is there, so cannot this one alpha plus beta, and this one alpha, cannot alpha plus beta and alpha minus beta. I think this one, yes. So this correct option is this one. Okay, so simple. If you know this formula, Ek equal to alpha plus 2 beta cos pi k divided by n plus 1. If you know this formula, you will find out easily this answer. Okay, next another one for allylic radical. Okay, Huckel's orbital theory can be applied to the allylic radical. This one, the possible values of E are, now which one is possible? So allylic radicals, so formula, this formula have to apply. So this one is like this, allylic. Ek equal to alpha plus 2 beta cos k pi by n plus 1. Here n, number of carbon atoms, how many? 1 2 3, and k, now you can consider k values 1 2 3 4 like this. Okay, now k value, so put the value. If you putting the value, that one, here 1, here 3 plus 1 4 like this, then you will get this one, then this one 1. Now E2 equal to, same here 2 2 pi, and here 2 3 plus 1, 3 plus 1 to 4 like this you can cut, then alpha. And if E3 same, you have to put that, you have to put the value, this one n value is 3 and k value also 3, then you will get this one. Okay, now this one is minus. Okay, like this. Now which one is correct? This first one, see, first one is in this one, alpha plus root 2 beta, after that alpha, then alpha minus root 2 beta. So which one is correct? Alpha plus 2 beta, alpha minus 2 beta, this one, and this one number correct. Okay, this one number is correct. Now this another one, this one is this E. This E is called orbital energy or electron energy. You can write like this. Okay, first this one, alpha plus 2 beta, this one is bonding. Okay, then non-bonding, and this one is alpha minus root 2 beta. Okay, this one. So like this, understood? So this one is about this one linear conjugated molecules. Now for cyclic conjugated hydrocarbon, the general solution N atom ring CnHn cyclic conjugated hydrocarbons. This one is formula. E equal to alpha plus 2 beta cos 2 pi k by n, where n equal to what? N equal to total number of carbon atoms in the conjugated ring. Total number of carbon atoms, how many carbon atoms are present? Okay, total number of carbon atoms. K equal to same, this K equal to quantum numbers identifying the MO equal to 0, 1, 2, ... n minus 1. But given the periodic and even symmetrical about theta equal to 0 nature of the cosine function, this permitted range of k values may also be written in the form. Okay, written in the form. So if n value is even, suppose n value is and this n value is, suppose n value is even number, now 2 4 6 like this. Okay, then this one, so k equal to 0 plus minus 1 plus minus 2 ... n by 2 like this. If n value is odd, so it's 1 3 like this, n value is odd, then k value 0 plus minus 1 plus minus 2 and ... plus minus n minus 1 divided by 2, this one. Okay, so this one is formula, this one for cyclic conjugated hydrocarbon. Okay, now some note, this one, note that the cosine function varies only between between the limiting values of -1 and +2, and because the cosine function is an even function, the energy depends only on, this is modulus k. Okay, modulus k. This one is nothing but is modulus k. This one, suppose k value is -1, then you can consider this one is a mod -1, that means a plus. Okay, that means -1 less than equal to cos 2 pi k divided by n. This one is less than equal to plus 1, hence this one. Okay, now if it is possible to represent equation as a geometrical construction, and this is illustrated below. Consider n equal to 6. Suppose is n equal to 6 means what? Carbon value. How many carbons are present? That means n value is 6. Then this is cyclic system, C6H6 benzene. Then the expression for E is this formula: E equal to alpha plus 2 beta cos 2 pi k divided by 6, where this is this 6, this one is what? Even number, carbon value. Okay, n is even, then you can write this on 0 plus minus 1 plus minus 2 plus minus 3 like this. Suppose k value is 0, then k, put the value 0, this is formula, then you will get alpha plus 2 beta, this formula have to by heart. Okay, this one, so this is 0, here 0, here also 0, then this one 0 means whole term is 0, so like this, alpha plus 2 beta, k1 same. Okay, you can consider this one, you will get alpha plus beta. K minus, plus minus is there now, this one k minus, if k minus like this have to practice, and this one. Okay, this one. Next this is 1. After that is k value is 2, then k value is 2, then you will get this part. Okay, this one. If k is minus 2, then you have to practice like this, same way, then this one, this one is same. After the k is 3, then you will get this part. Okay, so this much is enough, because this is hydrogen, this one is benzene, so benzene structure, this one 1 2 3 4 5 6. Okay, then 1 2 3 4 5 6 is there. Now this one is for this one value 2, here also 3 4 5, and this one is 6. Okay, now like this E this is energy, and this one have to write like this. See, because this one is what, first, this first one. After that this one and this one, then this one. Okay, this one and this one, then like this, after that again this one and this one like this, then this one. Alpha minus 2 beta. Okay, this one. So here how many, this is electrons, 1 2 3 4 5 6 now. This is first, this is ground level. Okay, 1 2 3 4 5 6 like this. So this one is HOMO, and this one is LOMO, highest unoccupied molecular orbitals, this one. Okay, now another is very important, this one, how to find out delocalization energy, DE, or delocalization energy. Sometimes this one is called pi bond energy. Okay, so delocalization energy, DE, equal to total energy minus ethylene unit energy. Okay, this is formula, very important, you have to by heart this formula. Delocalization energy, DE, equal to total energy minus ethylene unit energy. Now this total energy means, see here, total energy, so alpha plus 2 beta, see alpha plus 2 beta, here how many pi electrons, 1 2 electrons, huh? This is pi electrons, so here plus second case, in second case, see 1 2, then 1 2 3 4 4 into this part, so 4 into this part, so 4 into this one, minus. Now this one is ethylene unit, okay, this one have to by heart, ethylene unit. Now how many, this is pi electron, pi bond, how many, 1 2 3, that's why, so 3 into this ethylene unit, 3 into this ethylene unit, this one have to by heart, same. Okay, for ethylene same, 2 alpha plus 2 beta. Okay, after that calculation, then this one after that 2. So this one is what, this one delocalization energy of benzene is 2 beta. Okay, this one. After that is this one is butadiene. So cyclobutadiene is C. This one is cyclobutadiene. For cyclobutadiene, like this, K equal to 0. This is formula. Okay, cyclic system, this formula. So like this, here is 0. So here also 0. You can get 0. Then this one. After that K, if K1, this K1 value here 1, then you will get like this, then 2, and this one is 90, then 0, alpha only. Now if minus K, then this part. Okay, so you know this one is cos minus x equal to cos x. Okay, this formula have to apply here. Then this one is alpha. Now K equal to 2, here 2, then this one you will get. So cos 180 equal to -1, you know this one. So like this, so alpha this one. So see, this generally beta, this beta term generally is what? This is negative. Okay, beta term is, suppose this one is negative. Okay, the negative, the positive alpha plus 2 beta, here plus minus minus, this one negative part. Okay, so like this you can write like this also. So this one is actually this is energy. Okay, this one is first this part. Okay, this one, another this one and this one, so this one and this one, then this one. So there are how many electrons? 1 2 3 4 electron system now, 4. Then first 1 2, then 1 2, here alpha same this one. So there are 2 unpaired electrons, so it is undergo dimerization. So here how many unpaired electron? 2 unpaired electron, that's why this one is go dimerization. So you know this one dimerization in lower class. Okay, like this. Then now this one is delocalization energy. How to find out? The total energy minus ethylene unit. So ethylene unit, you know this one is this one, 2 alpha plus 2 beta, this one is fixed. Okay, now how many ethylene units? See, 1 2, so 2 pi bond, then 2, and this one is total energy. Total energy, know this one, the 2 into this part and 2 into this alpha. Okay, so this one like this, then equal to 0. So the delocalization energy of ethylene unit, sorry, this one is 0. Understood? Like this. So I hope you understood this one. You have to practice. Okay, and please subscribe my channels for further videos. Thank you once again.